In 1973, physicist John Bell highlighted a core mystery in quantum mechanics, the necessity of a subject-object distinction. While measurement results imply a subject, the theory fails to specify where or when this distinction occurs, leaving a fundamental gap in our understanding of physical reality. Joël Sternheimer proposes that this distinction isn't just for humans, it exists within particles themselves. By generalizing waves into scale waves, we find dimensions autonomous from spacetime. These dimensions are consubstantial with the subject, defining the field where physical laws and measurement interact at all levels. The journey began with V. Bargmann's 1966 realization about Lorentz transformations. He distinguished between active interpretations, changing the physical object, and passive ones, changing the coordinate system of the observer. This duality suggested that even elementary particles might possess an inherent subjective framework for measurement and interaction. To formalize this, Sternheimer adds two parameters, U and V, to Heisenberg's commutation relations. While U acts as a measurement unit, V represents a variable independent of spacetime. Together, they express the properties of a measuring subject, allowing for meaningful, non-random shifts in units during measurement. These new dimensions create an exponential mass spectrum for particles. By analyzing the synchronization of particle masses, Sternheimer identified a universal synchronization time, approximately 10 to the power of minus 12.5 seconds. This constant bridges the gap between fundamental physics and complex biological processes. This synchronization duration matches the transition from thermal agitation to Brownian motion in amino acids. It provides a code linking protein synthesis to specific frequencies. In the absence of a subject, protein sequences would be random. With a subject, they follow a meaningful, non-random, and functional order. We call these harmonic sequences proteodes. By translating the relative intervals of amino acid frequencies into sound, we can regulate protein synthesis. This genotic signal acts as an epigenetic regulator, capable of stimulating or inhibiting specific proteins to restore physiological balance in any living organism. Proteodeses mirror human musical inspiration, sharing laws of harmony and rhythm. However, they contain much higher information density. This suggests that human composers may have subconsciously accessed these biological melodies for centuries, using them to express feelings that resonate at a deep molecular and cellular level. Practical applications are transformative, from treating chronic migraines and cancer in Japan to increasing drought resistance in African crops. Genotic signals offer a non-invasive therapeutic path. This methodology treats the patient as a participating subject in their own healing process, rather than a passive object. Sternheimer's work reconciles the observer with the observed. By locating the subject-object distinction within the very fabric of matter, we move toward a more complete science. This new paradigm integrates physics, biology, and art, revealing a universe where meaning and matter are deeply intertwined.